this is my last reaction on the light independent reaction. So this reaction occurs without light, like direct sunlight. You don't need it. But what you do need for this light independent reaction to occur, what you do need is ATP and NADPH, which we just made in the last video. And these guys are high energy compounds, and we need this to make glucose. So the product of this is glucose, okay? So just to like kind of recap, for photosynthesis, it's CO2 plus H2O plus sunlight gives you C6H12O6 plus O2. Now we've already dealt with this. We split the water. We use sunlight to split the water. We made this, okay? We've already kind of dealt with that in the last lesson, but we haven't dealt with these two things that are really important. Anyways, so we are dealing with the Calvin cycle, okay, which is occurring in the stroma. And so the Calvin cycle is different than the Krebs cycle that you guys learned. So basically what you end up starting with in the Calvin cycle, okay, watch this. 1, 2, 3, 4, 5. 1, 2, 4, 5. 1, 2, 3, 4, 5. Okay, each one of these dots represents a carbon, right? So you have 3 5-carbon sugars, okay? So this is a 5-carbon sugar. Okay, so here's 1 5-carbon sugar, here's another. So you guys can see you have 1, 2, 3 5-carbon sugars, right? So this is what the Calvin cycle sort of, the stroma, it's in the stroma. We're going to start here, the Calvin cycle, okay? So this is actually not too hard, the Calvin cycle. Now, remember that CO2, So CO2 is part of photosynthesis. So CO2 actually comes in, and there's actually 3 CO2s that enter this Calvin cycle that's occurring in the stroma. And what we're going to do is we're going to add this that I am drawing at the end of this. This is the CO2 that I added, the other carbon, okay? So remember, each dot here represents a carbon. Well, now I added another carbon from the CO2. So here's the carbon from the CO2 that I'm adding, okay? So now each one, now I have 1, 2, 3. Hey, they're no longer 5-carbon sugars. They're now 1, 2, 3, 4, 5, 6-carbon sugars. So now I have 3 6-carbon sugars, okay? But this is very unstable, and so this breaks down immediately. So it breaks down immediately. It's very, very unstable. So when you add the CO2 to each one of these, this starts to break down. And so what it breaks down into is 3 carbon sugars. Okay, so this breaks down into 6 3-carbon sugars. Okay, so each one of these is a sugar, right? And I have 1, 2, 3, 4, 5, 6 of them. They formed after this broke down, right? After we added a carbon dioxide to each 5-carbon sugar to make the 6-carbon sugar, right? And now these are called PGA. Okay, so each one of these sugars is called PGA. So I have 6 of these PGA molecules, okay? Now these PGA molecules become another molecule called PGAL. Now in order to make PGA into PGAL, you need ATP input and you need NADPH. So basically, okay, these high energy molecules, so these 2 electrons that the NADPH are carrying are given to each PGA to make PGAL, right? So now each PGAL becomes energized, because you're actually using 6 NADPH, which are giving up 2 high energy electrons to each one of these, right? And so now these are 3-carbon sugars, but they're high energy 3-carbon sugars because they received these 2 electrons, right, from the NADPH. The NADPH, right, gave these, right, high energy electrons to each one of these. So each one of these received the NADPH's high energy electrons. And they needed ATP to facilitate the reaction. So the reaction could actually occur. You need ATP, right? So you actually need 6 ATP for this reaction to occur. And just so that you know, one of these PGALs leaves. So one PGAL leaves. And so because this one leaves, bye-bye. This PGAL, that's used to make glucose. So the one PGAL that leaves is used to make glucose, which you and I eat. But what are you left over? You're left over with 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 carbon sugars. Well, guess what? Add in some more ATP. And you can rearrange 5 3 carbon sugars into 1, 2, 3, 4, 5. 1, 2, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Okay, you can actually rearrange your 5 3 carbon sugars using some ATP back into your 3 5 carbon sugars that you started with, right? And then the cycle can repeat. Each 5 carbon sugar, right? Each 5 carbon sugar can accept a CO2, and a CO2 to become a 6 carbon sugar. There's the CO2 that we added on, and this 6 carbon sugar splits immediately to form 6 3 carbon sugars, right? And that you add in the NADPH, right? And this, remember, each one of these sugars is called PGA. You make 6 of them. Then you add ATP and NADPH, and the PGA gets transformed to high energy PGAL because all these high energy electrons that the NADPH is carrying is given to each one of these, right? And one of these leaves, one of this PGAL leaves, and this is actually what's actually been used to make glucose. And then you rearrange the 1, 2, 3, 4, 5 left. You put some ATP in, and that ATP is used to rearrange them back to what you started with, which is the 3 5 carbon sugar, and then the cycle repeats, right? So now you should know, when you look at your equation for photosynthesis, CO2 plus H2O plus sunlight, right? Now you should know that we made C6H12O6 plus O2. Now we know that the CO2 is used in the Calvin cycle, which is like the dark reaction. The H2O was used in the light reaction, right? So was sunlight. This was made in the dark reaction, or the light independent reaction. And this was made in the light reaction. So you can see that it's called the dark reaction because you're not using sunlight directly. But in order for this cycle to work, you definitely need the products you made in the light reaction, like the ATP that you made in the NADPH to actually make the glucose. So without the light reaction, this reaction cannot occur. Like, you need the products that you made in the light reaction, this ATP and the NADPH, in order to make this glucose, right? So that you and I can eat. So without the light reaction, indirectly, this cannot work. So it's only called the dark reaction because it doesn't use sunlight directly. Anyways, that's it for my lesson. I hope that helped. Take a look at Dr. Taylor's too if you need additional help, your textbook, and if, as always, you can ask me questions if you have any. Okay, take care, bye.